Hi guys, this is Web3 Boy and welcome back to the channel. And today we are going to be talking about delegation problem of Open Zeppelin's Ethernaut series, right? So let's just start. And this was something I was stuck for very long. It took me like 2 days to literally understand what's actually going on here in delegation. Because it actually it involved too many things at once for me, and it took me a long time actually to understand. I solved it once, I came back at it again, and then I kind of like solved it. I also referred back to this guy D squared, and he's very good. And I actually wherever I'm not able to solve the problems, I kind of like look at his videos, and it is very helpful. And this particular blog by this guy 0x Sage, and kudos to him, he also helped me a lot to basically understand. So this video, what I'll be doing is I'll be completely going through this particular this particular blog post only, because he has explained this level very beautifully, and you will be able to understand it because it involved a lot of things, because if you go by yourself, you'll have to like go through a lot, research a lot, but he has like compiled it and basically compressed it, and gave a brief summary of how to solve this particular problem, and lots of things to learn in this particular problem. So let's start. And I have opened everything. Let's just cut this. So what this level is saying is, the goal of the level is for you to claim the ownership of the instance you are given, right? So I have taken a new instance. I've already got my new instance, and it says what will help you. It says look into Solidity's documentation on the delegate called low level function, and how it works actually, and also how it can be used to delegate operation to on-chain libraries, and what implication it has on execution scope, right? Also, it says look at fallback methods. I've already explained about the fallback function, and also it says look at method IDs, right? So let's just first go through the whole code, and I've copied it in my Remix IDE. I'll just explain it right here, and we'll just after doing this, we'll just go through the solution, right? So here it is, guys. This is SPDX license identifier, and again we have this Pragma Solidity version that is basically defining the version of the Solidity compiler we are using. And here basically we have two contracts. This one is the first contract, that is a delegate, and this one is the second contract, that is delegation. Okay, so we have two contracts. So what we'll be doing today is, let me just copy this and use this pencil. Okay, so this is the first contract, right? Delegate. So what delegate is doing, basically it has a public variable that is named owner, and it is of address type, right? So any owner has to have an address, right? Then we have a constructor function right here. So what constructor function is taking a parameter as as an address type. Okay, so whatever we pass right here will be the owner, and owner is equal to underscore owner. That is whatever parameter we are passing will be set to owner, right? Then we have this pawn function. What this pawn function is actually doing is, it is setting the owner to whoever is calling this pawn function, right? So let's say if we are calling this pawn function, will be the owner of the contract, right? So let's just look at a delegation again, and what delegation is doing. So wait, okay, so here is delegation. Let's just go to the delegation function and look at it, right? Okay, so we have this delegation function. It has owner, okay, and what we are doing is actually taking this is delegate, and this is also delegate. So we are basically making an instance of the above library or contract, whatever you can say, whatever you want to say actually. So we are making an instance of it, and again we are in this constructor function, what we are doing is we are basically again this will give the address, this will give the ABI. So we are saving it in this particular delegate variable, and we have a contract right here, and again we are sending whoever is calling this deploying this will be the owner of this particular contract, like right. And we have this fallback function, and this fallback function is basically making a delegate call to this delegate library instance, right, instance of the above contract. So, and this particular thing, I don't know what it is, nobody was able to explain it, so I just skipped this part. I could not understand it, what this is actually doing. If a result this, I don't know. So let's this is it, guys. This is how the code actually works. And let's move on to our next structure. We'll be understanding what actually is delegate call, right? So I have this link right here. I'll just open it. So it will take us to solidity by example, and it is first time when I was reading it, it was like very hard for me to understand what actually is going on right here. But upon pondering multiple times on this particular contract, I was able to understand what actually is going on, right? So just don't be afraid of this delegate delegate word, because it was making me very nervous. So just look at it as a call function, right? Delegate call is just like call, but it has something very special. So let's just go through this. Delegate call is a low level function similar to call, right? So it is just similar to call, but with a special privilege, right? So we have to, let me just show you. Okay, so it says when a contract A executes delegate call to contract B, B's code is executed with contract A's storage message.sender and message.value. That means we have this contract A, okay? We have this contract, again we have this contract B, right? So we have B right here, okay? So this is actually what it is doing is, it is delegate calling, right? It is delegate calling. A is delegate calling B, right? So let's say B has this particular slot 0, and again this slot 1 as storage, right? And again we have A as slot 0 and slot 1 as storage, right? So if B has its own slots for storage 0 and 1, A has its own slot 0 and 1, but when A is delegate calling B will just B's storage will not be used. Instead A's storage will be used in place of B's storage, right? Let's say we have X as a variable stored in 0th slot, right? And then we have Y as a storage stored at a 0th position in the storage slot, right? So when A is delegate calling B, what will happen is X will replace Y at 0th position, and Y will not be used actually, okay? Y will not be used, and X will go over B's storage, okay? And at 0th position X will be there, right? So this is how delegate call is actually working internally, right? So I hope you guys have understood it. It took me a long time to understand, but finally I was able to understand it, right? This is it, guys, and let me just clear it out. Okay, so let's just go through this particular contract again. So we have contract B, we have contract A, right? So we have contract A and contract B, and again what is actually happening here, we have contract B. Contract B has num as a variable, sender as a variable, and value as a variable, right? And again, A has num, sender, and value as a variable. So num will be at slot 0, right? Num will be at slot 0, right? Sender will be at slot 1, and value will be at slot 2. I don't know, it is not 2 anymore. Okay, it is at slot 2. Here it is also at slot 0. Here it is also at slot 1. Here it is also at slot 2, right? But when A is calling, when B, okay, this is A. When A is delegate calling B, what will happen is these storage slot will just replace these storage slots, and these storage slots will not be used because A's every variable at A has replaced every variable at B's storage, right? This is how delegate call is actually working internally. I hope you guys were able to understand it. I don't know, it was very tough for me. Again, moving on. So this has a function set vars. Set vars is actually taking a num. This is num. Whatever we are sending as a parameter, it is going to be stored in this num variable. Message.sender will be stored in sender variable, and message.value will be stored in value variable, right? Contract A has these three variables, and again, what we are actually doing here is we have a function that is set vars. We will be passing an address of the contract, and this contract address will be the address of this contract B, right? When we are passing it along with the num variable, num parameter, it will be payable function, and here we are delegate calling, right? So how we are delegate calling actually? We are this is the contract address of contract B, and contract B is actually, we are delegate calling contract B, and we are actually calling this particular function in contract B, right? So set vars is actually in contract B, and we are calling this particular function, and we are setting, this is the variable that we are setting, right? This is how you invoke a function from external contract by delegate call. So contract A is actually delegate calling contract B, and we are invoking this particular function and passing this parameter, that is num, right? So I hope you guys have understood it, and let's go to this line. The fourth point is very important, that says remember that in Ethereum you can invoke a public function by sending data in a transaction, right? What this is actually telling us is let's just open this, right? So we have this pawn function right here, and we cannot access a pawn function, right? Let me show you. If I want to call pawn function, right? So I'll say await contract dot pwn, right? And let's see what happens. Okay, so it says pawn is not a function, right? But we are actually saying that pawn is a function that is available right here. Okay, so what actually this particular problem is doing is it is giving us this contract, not this contract, right? We don't have this access to this contract. We actually have access to this contract. So the instance is basically the address for this contract, not this one, right? So we cannot access the pawn function from this contract, but there is a catch right here. Delegation can actually delegate call to delegate contract, right? And while delegating, we can invoke this function by sending a data, right? So how we'll be doing it? We first let's just see the contract address. Okay, so await contract dot address, right? So we have this address, right? This is the address of delegation contract, but not the delegate contract, right? So we have the address, and there is this web3 library, web3, and what web3 dot this is it. So Web3 is actually, what Web3 is doing is Web letting us contact to the smart contract via the console, right? So if I'm writing Web3, it is basically this console that is trying to contact this particular smart contract, right? So this is Web3. I'm using Web3 library, and again I'm using utils from it, and I am invoking pawn function, right? And I'm basically invoking the pawn function and converting it into SHA-3, right? So the SHA-3 is basically the hashing algorithm. I'm taking out the hash of pawn function, right? So I'm doing it, right? So we have this hash, right? We have this hash of pawn function, right? And again what I'm doing is I have this, okay, this. So I am sending a transaction. I'm sending a not a raw transaction, but with data, right? I'm sending this data. So I'm saying await send transaction, and from variable, that is from whom this particular transaction is coming from. So this is our contract address of MetaMask. So let's see our contract address, I mean our address of the MetaMask. So this is the address 7FD 0x7FD. So this is us sending the transaction. This is the contract address 0xe1, that is contract address 0. This should be 0x, I mean this should be this, it should be this. Okay, this is the, I mean this is where we are sending the transaction, and this is data, right? So data is actually the SHA-3 hash of pawn function from this contract, right? So this is how we are sending a transaction, right? So I am sending a transaction and I'm confirming it, and after confirming, let's see if we have the owner or not. And one more thing, I'll show you who's the owner of the function, I mean owner of the address. Owner of the contract. So he is the owner of the contract. I don't know who I mean this is obviously this OpenZeppelin Ethernet platform there. Okay, we have mined, and let's see if we have, okay, now we have, basically what we have done is we have the ownership of the contract, right? So what we did actually is we invoked the function, that is pawn function. We took out the hash of the pawn function and we sent a raw transaction, I mean we sent a transaction with data. That data is actually pointing to the pawn function, and we are sending this transaction, and while sending this transaction with data that says we are trying to invoke the pawn function, we are invoking the pawn function. And while invoking the pawn function, what actually pawn function is doing is it is setting the owner to message.sender. So basically we gain the ownership of the contract, right? Okay, so this is how, I mean we did it. This is how we have gained the ownership of the contract, and it was very tough for me to understand it. I hope you guys have understood it, and I hope I was able to explain it correctly. If not, please forgive me, because I'm also a beginner and I'm also just learning. I just wanted to share these things with you guys. If it was very helpful, or if it was helpful at all, please subscribe to my channel and like it and share it with your friends so that they can also learn along with me. And this is it, guys. Oh, one more thing, I forgot to submit the instance so that it shows that we have completed the challenge, right? I forgot it. Forgive me that I forgot it. I'll just confirm it, and I'll show that we have completed this challenge. Otherwise you might think that I have not completed this challenge, right? And kudos to this guy. This guy has helped me a lot. 0x Sage, a very helpful blog, and it was very helpful for me to understand it. I want you guys to please go through this particular blog multiple times if you guys have not understood it. But okay, here we have, well done, you have completed this level. So finally we have completed the level, And this is it, guys. This is it. And again, in the next video I'll be doing this post and vault. So I'll be doing this, and I'll see you guys in the next video. Till then, bye bye.